Hey everybody, this is Larry. This is virtual contest Leetcode. Ooh, free button. Binary Biweekly Contest 177. Hit the like button and subscribe button. Join me on Discord. Let me know what you think about this contest, these prompts, and everything in between. This is a virtual contest. This is a live attempt of the contest. So yeah, each problem's actual explanation will be in its own video. This is just so you can see for reals how someone would solve this, or at least someone like me. Maybe not someone, just me. I don't know how to say it, but yeah. All right. Without further ado, let's go. All right. Let's do a quick countdown. 5, 4, 3, 2, 1, go. Do. All right. Oh, because I'm waiting for the right side to go, but maybe I should just read it anyway. This thing x is less than y, xy have different frequency amount of pairs. Man, this is just a lot of reading. But we have frequencies anyway. But x is less than y, and 100. So we're going to do some loops, right? Choose the pair of the smallest value of x. Okay, I guess so. For x in range of in nums, for y in nums, if f of x is not equal to f of y, then is it indexes? No, it's x, y. xy, right? This is array. If something like this, right? Maybe I should restart my computer before, but oh well. Computer's a little bit slow. Maybe I'll do it afterwards. All right. You're given a string S consists of lowercase English letters and an integer K. 2 Yigo characters in the current string S are considered close if the distance between the index and most K. Okay. Yeah, fine. 2 Yigo characters. Okay. When two characters are closed, the right one merges to the left. Merges happen one at a time. The string updates. Okay. Return the resultant string after all performing all possible merges. Okay. Yeah, that's what I was looking for. Okay, multiple merges always merge from the smallest left. The smallest right. Okay, so that's the biggest thing, right? Yeah, I mean, I think that's fine. We would have something like right, and c dot append index, and then while length of indices of c is equal to 2 and indices of c of -1 minus indices of -2 is at most k, then indices of c dot pop, because we remove this. Yeah, I think that's right. Right. Okay. Yeah. You can even do it a little bit smarter than that, but it's fine. And then oh, length is only 100. Maybe I should have done something dumber. But okay, either way. man. I'm just being dumb today. Something like this. Right. I have to convert it to string. Forgot. ABC. Hopefully I understood it right. If I understood it right, it should be good. But I did not understood it right. Huh. What did I misunderstood it? Okay, so we have this. We move this Y. Oh, no. I am wrong because now the indexes are closer. Oh, poop. That is true. That's true. Wow, that is sloppy by me. And the funny thing is, if I did it like naively, it would have been fine. It was n times k. That's why I could rework this to be smart, but it just takes too much effort. The funny thing was that, like I said, I think I could have. The funny thing is that, yeah. If C, something like this. The funny thing is, if I had done it this way, what was the answer? I forgot. The funny thing is, if I did it the non-optimized way, I would have gotten it so quickly, like you saw. But it is what it is. I didn't actually. I will admit though, I missed the n is equal to 100. I thought it was going to be bigger, but maybe it was a Q2, and I should have looked into it a little bit more. It happens, I suppose. Okay, Q3. I have different parity. One is even. I guess that's reasonable. You choose any index and it goes by 1, decrease by 1. Okay, that seems straightforward for this one, maybe. But minimum possible value of. Huh. That part seems a little confusing. Oh, I'm not. I don't know. Okay, so the first part seems straightforward. But how do I do it in a way that is binary search? Maybe. Okay, yeah. How do I write it? Yeah, okay, fine. Yeah. No, not even binary search. This is an annoying one. I don't think it's hard, but it is annoying, I think. Maybe. I don't know. Let's actually come. Oops. If odd is first, let's do evens first, then I can write this. So that would be this, and then you can do odd first, right? Yeah, whatever. which I guess is like, yeah, maybe it is. You can just write like count even. Now we have a double negative thing, but I think that's fine, maybe. Right. Okay, so now we have either even or odd, but we don't even have to change it. Okay, so then now. Okay. Oh, if okay, then we have to consider it, right? Min after. Okay, so what is the current min, right? That means that if it is equal to min, we okay, fine. Min of arrays, right? So yeah, okay, so we have two numbers that we care about. We have mins and we have max. I guess we should do this anyway for all of the. Okay, now if count even is then we want to say the only thing that matters is if it's equal to min, right? So if I do, so that means that we have to change this one for even, right? If raise of I is equal to min, then we add. Okay, so then that means that actually we don't even need a loop on this one. Well, we don't need a loop on this one, right? Because then here min we just plus one, right? So okay, so that means that actually if min mod 2 is not equal to no, I mean, I guess we actually matters what index it is. Maybe I lied. So here, so we just changed this one, but then now we have to do the opposite, right? So we cannot change this for even. So then we have to keep this. So keep min is equal to true. Else if okay, right. So that's one possible thing. This is so annoying, but okay, fine. New min is equal to if keep. Oops. So then now here we would do and I probably should have abstracted this, but I wasn't maybe not slick enough about it earlier on. And I don't want to go. I don't know. Maybe I just can't think about it right now. Right, and then now we do the other thing. And this is the part we should have abstracted, but because it's very easy to make a mistake. But I think all I have to do is change this, but I could be wrong. Okay, so then now we return min of count odd, count even, and then best. Hopefully that's rightish. I mean, I forgot that I, for some reason, abstracted, but that's okay. I thought I was gonna write something a little bit different. That's why. Is it OS? Where was it? Oops. Oh yeah. Oh. 300. YOLO submit. Hopefully no silly mistakes. I thought I count. Because the 7 you have to change one of them. This is a legit wrong answer. I actually did not consider this case. I'm just trying to think about how to fix it. I know that the answer is because you're forced to. So okay. I think this is only a. Is this only a? Yeah, I think this is only a case if they all the same numbers, but I can't. I don't know how I would implement that necessarily. How would you, because the answer can never be 0, right? So actually, maybe that's fine. Because the answer can never be 0. Oh, it can be if it's not one number. So if it's not one number, then it can never be 0. So maybe I'll special case the other way. Hope that's right. Let's see. Okay, so yeah, that is a case I legitimately missed. I think I thought about it very briefly, but then I just didn't get to it, or I just forgot it by the time I got to it, or whatever. To be frank, but yeah. All right, let's go. Q4. All right, sum of k-digit numbers in a range. It was sloppy contest already, but L, R, and K possible integers with k digits. Digit independently from LR, zeros including the range, leading zeros are allowed, okay. Return integer of sum of all such numbers. Sum of all the numbers. Okay, so we have, what's k again? K could be a lot of digits. I from that I suspect already it is going to be matrix multiplication or matrix exponentiation. But we'll have to, let me reread it. Exactly k digits. We have so many digits. But that's a lot of digits. Maybe there's just like a very dumb pattern as well. But we'll see. Okay. So we could do this a digit at a time, I guess, right? No. Well, yes, you can. Yeah, you could just. Well, Well, let's try a digit at a time, and we'll do a for loop k type thing. I know it's wrong, or at least its time is not fast enough, but yeah, maybe we can figure that out. K is equal to 2. We have, that means that for this digit, okay, so yeah, ask another way, how many times is the first digit a 1? Right? And that is just, yeah, okay, that's straightforward, right? But then now we just have to figure out how to do it for k is equal to 10 to the 9, which I guess is the hard part. Okay, so then now for I in range of L, is it the hard part? Because it is all independent. So that means that for each digit, we just almost like you multiply it by shifting digit, right? But how do you get that? Like all ones. Divide and conquer, I guess. It's probably fine, honestly. Yeah, I guess you could just divide and conquer, so then it's just whatever, right? Yeah, okay. That makes sense. So then you have something like this, right? Whatever. Something like that, right? And then now we have whatever. And you could probably maybe even do it without divide and conquer, but that seems like at least a way to prove the bounds for me. Almost like the way that you do from like FFT or something, right? Okay. Yeah, okay. So then now, how many times does it come up? So we have how many k digits? So k minus 1. So we want, so that's number of other digits. So we want a power of what are we doing? Oh, let's just say r is equal to the range r minus r plus 1. Right, yeah. And then it is going to be, yeah, r to the k minus 1 with the mod power, right? So this is, I don't know, just count, right? Okay, so then now for each digit, right? So then now we have to sum it up over all the things, right? So then we just divide and conquer on k, right? So yeah, so maybe we have a g of, what is count? Oh, it's count times x, right? Because each of that is the contribution. So then maybe right? Okay, for each digit, but total is equal to count times x. It's just sum of all the counts. And then now we have, so this is for each digit. Now we have to sum it over. So then, okay, total k, right? Yeah, something like this. And then we'll just as a helper, right? So here we have the total and then the count k left. So then now we have divide and conquer, right? So if k is equal to 0, we return 0. If k is equal to 1, we return total. Otherwise, we have if k mod 2, I always forget how to write this. Well, I mean, this is, I haven't written this in a long time quite this way. But okay, so if this is equal to odd, okay, if it's equal to even, then that's easy-ish, right? So then start with a smaller number, right? So let's say k is 2. If it's 2, then you want 1 on the left side and 0 on the other, right? So then you have because it's not, man, it's been a while. So okay, so you have k left, and now you have the left chunk and the right chunk, right? The right chunk is just going to be k. Is it k divided by 2? No, it doesn't feel right. Man, because it is the same as no, it is not the same as FFT, but it basically the way it is to, and maybe I need to, I have it in my head, but maybe I'm not articulating it right in my head, so I want to write it down. So basically, let's say k is equal to 100, so divide by conquer, divide, I can't even say anymore. It's going to be equal to the, what does k equal to 100 means? Oh, I'm just getting, this is actually, the way that I'm writing it is confusing, but that means that we have 100 digits, 100 digits left to consider, and k is equal to 100 represents, let's try something smaller. So if k is equal to 5, that actually represents that we have to do one, right? So we have to multiply total by this number so that we have represented for each digit, right? That's how I'm thinking about it. Let's say 6 for an even number for now, and then the divide conquer is that we want to divide this to be and right? Okay. So that's actually what I had in my head. Okay, and then we divide conquer it out. So yeah. And of course, the recursion is just that they overlap. So okay, so if k at 2 is equal to 0, then you just have half of this on the left. So then yeah, it is k divided by 2. So you want g total, right? So maybe s for subtotal. And we probably need it anyway for either one, so we'll put it here. And then it's just return s plus s times 10 to the k, 10 to the k divided by 2, right? Yeah. And then of course mod it, and that's it. Else, if it's odd, what happens if it's odd? We have 1, 2, 3, 4, 5. K divided by, so we have 5. 5 divided by 2 is 2. So then we have something like this instead, right? Depending on how you write it. I mean, you can write it either way, but something like this, right? So then now we have return s plus, or s is equal to 2. Okay, so yeah, so maybe we can write this still, and then we add it again one more time for 10 to the k minus 1, maybe. Because yeah, so then basically the idea is that we sum up it instead, something like this. K is 5, so this is 4 digits times 10 to the 4th. Something like this, I think it's fine, right? And I think that's it. I mean, we're mostly close. Did I forget something? Because it seems like I'm a little bit off, clearly. Like, I'm at 68. But I think we're in the same. I think our ideas are right. Maybe this one is wrong. I think that's the thing that I wasn't super well. Or maybe this is wrong. Maybe. I don't know. How do you get 68? Egg. Alright, let's just try p of x. One is 22 plus 44. So how do you get plus 2? I mean, this is right. Did I mess something up? How did I get 68? I guess that's the answer. Like we add these two. Huh? Oh, I see. Because I'm dumb and I reused or probably. Because there's some like weirdness anyway. So what I want is actually, okay, fine. I don't know. That is a funny way to, I mean, I don't know. Maybe that's not enough. But that's definitely at least something. Okay. There we go. That is a pretty dumb way to get a to debug. But I do that a lot. That's the one thing that I'm bad about Python in. Maybe I should check performance actually. Wait, maybe we could have cached this. No, we only. This is just whatever, right? Oh no! I forgot to mod power this. That's why I was like, why is this so slow? Well, I mean, it would have been wrong anyway. But or timeout even if I didn't. But oh. This is the no, okay. I was like, is that the classic input? No, wait, is it? Huh, this is wrong. I just kind of YOLO submitted it. So okay. All right, let's try again though. Nope, still wrong. Okay, I just kind of eyeballed it and was wrong. So that's kind of sad because that's the example, right? Okay, so it is wrong. I just kind of looked at these two. Why is this wrong? Oh, there's only one number. Huh. Where did I get this from? But okay, let's double check. I mean, I think the idea is probably mostly right, but definitely just a lot of potential mistakes. How many times does it come up for each digit? So k minus. Is this part wrong? So k minus 1, so there's 9 digits, range is 1. So no, this is just going to be 1, right? Let's put it in the debugging anyway. just to make sure. Yeah, so this is 1. So then maybe it's this part. So you have 10. I mean, at this point, I'm not super certain about. I think that's definitely a possibility. Unless like I did this wrong. So K is equal to 2, right? Okay, let's print this out actually. KS. Ah, I see. So I definitely do some doubling wrong. So okay, so for 5, this is half, right? But then I'm doing an extra 1 somewhere. For 10. No, is it? This is half. But no, because well, this is definitely not half of whatever, right? Because this is 12 digits if we double it. So that means that this is wrong. So 5 is 55. What is 5? 555, right? 555. 10 is. So 5 should have 5 digits, but it's returning 6. Okay, so K. So I mean, this was very sketch, suppose. But all right. Okay. So yeah, so why? How did it double that way? S. Okay, so I just do it. I mean, I clearly did it wrong, but so 55 times by 100. How is? Oh, this is not S. This is 1 instance. Okay, that's why I can confuse. Okay, I see. I mean, the idea is right, but I just kind of got lazy with this S. This is not S. This is 1 instance of the digit, so we have to actually return the digit. So D for the digit. Whoops. Yeah, maybe we can just do this for G X. Yeah. Okay, that was pretty dumb actually, but okay, let's write this for now, so I can fix it. Where's the other G? Oh, okay. Silly mistakes aside. Why? Oh, I feel like this should be. I mean, I think the idea is right, but I am definitely maybe a little bit too slow or too dumb on like certain details. Clearly, I thought I added this. Is this the input? I was like, oh, this is the input. I got wrong in the input. Or the example case again. I just didn't see it. Okay, 144. Why is it 144? 0. We don't care about 0. That's fine. So okay, so this is the classic thing where this is not working. So D. Am I missing D somewhere? X is the thing, right? So D. So this should not be. Oh. No. Oh, okay. So it's not D. It's total. Okay, that makes sense actually. Because it's 1 instance of the total, not 1 instance of the I just got confused because in this case it was 1 digit, but okay. Now I have to get rid of those again. And honestly, the only reason why like all these mistakes, well, it's very sloppy, right? Because both of these are examples, like I just didn't match the example, so that's just one way sloppy. But 2, honestly, even if it wasn't for that and I got wrong answer, it was just because it's because I was rushing it. I probably had to slow myself down and just be more careful, right? And my rushing it and trying to shave, I don't know, a minute, 2 minutes maybe, it cost me 10 minutes of penalty, and that's like obviously not great, right? Because these are like I even knew that, because maybe you could say that the first no, well, I mean, I deserve at least one wrong answer, because this would have timed out anyway. So there's a wrong answer there, even if it's not even if it didn't come up. But this one, I knew that this was an issue, and I just didn't think about it enough. Yeah. But overall, I mean, pretty fun contest. Honestly, I dig it. The problems are fine. I am a little bit silly, but in the way that I did it, but yeah. Yeah. Let's do a quick retro. I mean, I got so many wrong answers. It's kind of silly. Let's go over them. Q1 was fine. Q2, what was my wrong answer? If my computer loads. Oh yeah, I forgot. I was using the initial index, and then when you remove indexes, I just didn't do it. But I think there's a way to do it the way that I did it, but yeah, this is. I say this a lot, where like you rather be correct, and with n is equal to 100, I should have done this immediately. But I also honestly didn't think this needed to be an n square solution or whatever it is. So that's why I jumped to it, and I didn't think about the complexity. But because I only saw this constraint after I got the wrong answer, or maybe when I was already close to done. Either way, like I had committed by then. Because yeah, I mean, this is pretty silly. This one, what was my wrong answer? Oh yeah, for this special case. I don't know. This one, I feel like it's on the edge for me, in the sense that I could have gotten it, and I could have also not gotten it. Because it was top of mind, but I just kind of lost track of it, honestly. And this one is just silly. We just talked about it. So yeah, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy, take good mental health. I'll see y'all later, and take care. Bye-bye.